Assalamualaikum and hi everyone. I am Aisyah and today I'm going to tell you about what is hereditary spherocytosis. So, hereditary spherocytosis is genetically determined by hemolytic anemia where the RBC characterized in a sphere shape. So you guys might be thinking, wait, how can our RBC, which normally shape is biconcave shape, becomes into a sphere shape just like you see in the picture? So now, what about the symptoms of people who has hereditary spherocytosis? Well, it all depends on the level. The mild to severe of hereditary spherocytosis, but usually the patient will have pale skin, fatigue, anemia, or probably enlargement of the spleen, may have gallstones. The form of hereditary spherocytosis can be categorized in three. So the first one is mild, moderate, and severe. The differences between normal RBC and spherocyte RBC is both of them are 7 until 8 microns, but normal RBC is less volume, has more surface, biconcave shape, and more flexible, while spherocyte RBC has no centropeller in the sphere shape, less surface, more volume, and not flexible. Structure of RBC membrane consists of protein. The interactions of RBC membrane, protein, and lipids can divide into two, which is vertical interaction and horizontal interaction. Vertical interaction is perpendicular to cell membrane. It includes interactions between skeletal lattice on cytoplasmic site to integral protein and lipids of membrane. It stabilizes lipid bilayer defects lead to uncoupling of lipid bilayer from underlying skeleton, and selective low lipid layer microvesicles form protein include ankyrin, BAN3, glycoporin, and protein 4.2. So easy to say, vertical interaction holds with horizontal ankyrin attached with 4.2 and special channel made of protein called BAN3 protein. Another set holding vertical and horizontal interaction is 4.1 and glycoporin C. For horizontal interaction, it consists of two peptide chains, which are alpha spectrin and beta spectrin, and have relations with each other. The end of the tetramer attached with protein actin. So now we move on to the pathophysiology of hereditary spherocytosis. So before, how can red blood cell become sphere? So we need to go like way back to the early process of red blood cell, which is normoblast. If the normoblast has gene, so if deficiency happens on this RBC membrane protein such as spectrin and chirin and BAN3, it definitely means like the protein doesn't really like be used or built well at all. So when the mutant red blood cell goes out of the bone marrow into the circulatory system, it will when it go to the narrow pathway of the circulatory system, such as on the spleen, which only let 2 microns cell pass through it, it become harder, and it will left a piece of the membranes. Spherocyte cannot switch through, and it just now release the microvesicle. It left a piece of membranes, and it becomes spherocyte. It become the shape of the sphere. And then when it went through erythrocytosis, and the cell could become hemolyzed. It will be hemolyzed, it will go through hemolysis, or probably if it doesn't go through hemolysis, it will release more vesicles, more microvesicles, and it become microspherocytosis. Membrane defect is primary 50% unchirin and deficiency secondary band 3 and spec 3. So what is the lab diagnosis for hereditary spherocytosis? First is CBC, or should we call it FBC, which is full blood count. Second is PBF, peripheral blood film. This film shows that spherocyte is small and doesn't have central powder zone. In spherocyte film, you can also see polychromasia and biconcave erythrocytes. So as you seen on the picture, other than polychromasia and the erythrocyte, you can in PBF of hereditary spherocytosis, you can also be found target cell, anisocytosis, poikilocytosis, polychromatic cells, and nucleated RBC, which usually present in severe cases, and others. Third, osmotic fragility test. Fourth, biochemistry test. For the biochemistry test, the result usually the bilirubin is increased, urobilinogen is increased, methymalbumin is increased, heptaglobin is decreased, and hemopexin is decreased. And fifth, we can just by red membrane protein on the SDS gel page. SDS page shown the simple protein pattern of RBC membrane. So that is all that what I'm gonna tell you about hereditary spherocytosis. Thank you for watching this video. I hope everyone love it. Bye.